is algebra, and another one is geometry. So, how many of you graduate in the US, the high school? So in high school, think about your math curriculum. 1 year, algebra. Next year, geometry. Then the algebra, geometry. So basic introduction of algebra is like the 6th grade, 7th grade, so in the middle school. Yeah. Then followed by geometry. Then the algebra 1. Then geometry 2 or the advanced one. Then the pre-calculus, then the calculus. So there are two parts of the mathematics. One is the geometry, another one is the algebra. First, the geometry. So long time ago, in your sociology class, how many human civilization places did you study? How many the human civilization place? Like the Mesopotamia, do you remember Mesopotamia? And Yangtze in China? And in the India? Yeah. So that Nile River. So these four, the area of the human civilization place. Why? There are common things. It's a river. Why river?
Main source of fresh water.
Fresh water, that's one thing. But you can get the fresh water in the lake also.
For crops.
Crop. Why crop is better in nearby the river? Just water? Yes, it's from water.
Soil is fertile.
Yes, soil is fertilized. Because the mostly such the human civilization place is the end of the river, which means it's a delta area. So delta area they have flood every year, but the flood is not always bad. So after you crop and the farming, it's a flush out everything, then new soil is coming. It's a fertilized. It's the natural fertilization. So the people actually travel on like the first hunt. They fight with the animal, but they realize that if I capture the animal, then we can have the farm for the animal. Then they move around because the animal need the fresh the plant and so on. So they move around. Still, some of the people are doing the Mongolia and so on, but it's not guaranteed. So they found the crop or farming to get the rice and such a thing. So they try to find the best place that is delta area. Then that they realize that every year they can get many the food and so on. The problem, once you farm and such a thing, the problem is so many people. If you are living together with other people, not always a good relationship. They fight each other, and this is mine after the flooding. So my land is up to here, but so no, so mine is up to there. So like that, they need what? Government, security for security reason, and many other reasons. They need the government. So government is the style of the government is there's a king and there are slaves like that. Eventually, still we have the same social organization. Community is a government, but they have the different the policy like the capitalism or the community. But the government, the main purpose of the government is to live safely for the people. Then, the government needs what? Money to organize and to operate the society. So they need to get the money from the people, which is called tax. So tax is any government without tax, maybe small country in the Polynesia if they have a huge natural resource, but most of country collect the money from the people. That is tax. In Connecticut, it's really high. So couldn't imagine the salary is like that when I received the tax report every time. So government take out almost 40% of my 30%, but including health, the insurance is almost 40%. So, but anyway, so government need the money. So in the, for example, Nile River, so many people farm and the crop, and then the problem, so it's based on simply the size of the land, right? So collect the money. But next year, after flooding, they fight each other. So government hire the mathematician and the philosopher. Can you measure even after the first out, measure exactly the boundary of the land for you and the other people? So at the time they use geometry. So like the mountain, top of the mountain will not be changed. We have a big tree, so but there's a river, so they calculate the ratio between the angle and the distance. Sometimes you can measure the distance, but sometimes you can measure the angle. So using trigonometry, you can actually decide the other area or side, even though you do not measure exactly. You can calculate. That is geometry. Then the geometry starts from the more practical thing in the daily life. Then the Euclid actually finalize all the fundamental of such a geometry. What is the point? What is the point, by the way? Can you see the point? Actually, point does not have any size. It's invisible. But what is the line? Euclid define the line is set of point. Even though point doesn't exist, but I say exists, but it's not visible. There's no side, but the line is a set of like that. Then that is the Euclid geometry. It's the title of the book is the Euclid the origin. Okay, origin. Suddenly I forgot. Original, whatever. That is very important, not only for the mathematics, but for writing style. Most of the English writing follow his way, like the definition and proof. I suggest. Then your hypothesis and proof. Mostly English writing has your opinion, then support and conclusion. That's the way of writing in the Euclid. So we follow such a thing. Anyway, so that's the geometry. Another people try to solve the problem in our nature. So not always we can measure the distance or angle, so on. Why not? We consider something. We try to find always the unknown value, unknown variable using evidence. So why don't we use the set of number? But sometimes we don't know which one is which. So unknown variable. So x, y, z like that. Okay. Then there might be rule. So if a plus b is gonna be c, they are always true. So if I know a and c, I can calculate the b, which is algebra approach. Algebra is based on equation. Equation means what? It's a sentence. It's a natural language in number. Okay? But it's always equality. So left hand side and right hand side are equal. Okay? And using the property, we can evaluate the unknown variable. If we find the unknown variable, evaluate, then we solve the problem. That's the reason in mathematics, a lot of problem solving. So think about, remind, such a problem solving in mathematics. Huge description. A, B, travel from the city A to the B, and the day speed is 10 miles per hour. The other side is 20 miles per hour. They meet the 20 minutes later. What is the distance like that? Even though it's described in English, your goal is to translate into mathematical language, which is equation. So first thing is you need to define what is the unknown variable, distance. And what is the known variable? Like the speed of the A and speed of B. Then next thing is the translate English into the equation, mathematical language. So x plus y equals c, like that. Then I know x and they evaluate the y. Then we solve the problem. So it's an algebraic approach. So algebra and the geometry eventually combine into the calculus level, pre-calculus. So there's analytic, the geometry, and even the same problem you can use either algebra and geometry, then combine with the calculus. So calculus is the ultimate goal of our higher education mathematics. Why? We can consider any the effect, the problem, our nature as a curve. So if we like a linear and quadratic and or the something, whatever, so I'd like to know the stock market price tomorrow. So can I create the equation for the stock market? Then we can make the money, solve the problem. So any kind of problem in our nature, we try to create such a curve. Then we should know what is the curve, what is the property of the curve. How do you know? Where is the top of the curve? Where is the lowest point of the curve? Like the minimum and the maximum momentum. How can you calculate the momentum? So curve is like that. It's slope, so plus, then going to 0, then going to minus. So top of the mountain is a slope is 0. Then how can you calculate the slope? Derivative. So you can derivative equals 0, that is the momentum. So momentum is the important momentum of my life. So reading Professor Lee, like that. So momentum of the curve. And what is the slope? Then we can, even though we do not know exactly the shape of the curve, we can understand. So that is the purpose of the curve. So I love calculus. So calculus solves a lot of problems. So we can use such algebra. So Dr. E.F. Code suggests to use such an algebraic approach. To use, we have a relational model, relation set. So why not using the similar approach we have used in mathematics? To deal with the number, we have an operation, we have the number, and so on. To deal with the data in relational model, why don't we use the similar operation used in the mathematics, especially set theory, because the relation is a set almost, right? So if we can use the same operation that employ to the relational model, then we can do whatever we want. Whatever means CRUD, the create, insert the data, and update the data, select the data, or delete the data. Can we do such an operation using what? The algebraic operation using the mathematics. So that is called relational algebra. So relational algebra is the language, okay, operation for what? Relational database model. So once we create the relational database, like the table, we should access the data, insert the data, retrieve the data. How? Relational algebra provides such a way. So relational algebra is the number of operations, like the plus minus, the multiply. So we are going to learn such an operation. Then, once, not too many, we have around 10 or 12 such a relational algebra operation. Okay? Then, Dr. E.F. Code suggests up to there, the relational algebra. But later, people implement such a relational algebra operation using programming code, okay? Which is called C code language. So C code is actually entirely based on relational algebra. Okay? That is the reason, if you understand such a background of the C code, later somebody use a C code style language, then you guys can understand what is the purpose, how you can use. There's such a different language. Okay, so in chapter, I'm going to skip the jump to the chapter 8, skip the basic and advanced SQL, which is chapter 6 and 7. After we cover the relational algebra, we will go back to the SQL. So, relational algebra has such a number of operations. So, in other words, relational algebra is kind of a language for database. It's kind of a language. So, think about the English. Any language has one. So I think that it was 13 years old when I started the English first time. So the elder sister gave me dictionary. It's really deep. Then she suggested me to memorize a word. That is the kind of basic. It's totally wrong. So I really hate any type of language because I start the first, second language memorizing the whole word vocabulary. It's not possible. I really hate such a thing. But it is true. The language is based on the vocabulary. So without understanding, knowing the vocabulary, doesn't make sense. The understanding, or comprehensive, such a thing. So we start with the operation. Operation is kind of vocabulary. Then, so next thing, once you know the vocabulary, you should know the grammar. So subject, verb, object, right? I go to school. So like that. So we have such a structure. It's a grammar. So I study the English first, vocabulary and grammar. I never taught in English until the college level. I only studied for the grade. So that makes me really, still I don't like to study any type of language, even including the mother tongue language. So anyway, it's a personality. But after you learn the vocabulary, next thing is writing a sentence. So same thing in a database. So one operation is not enough to access complicated data. You need to combine several of them. That is called the relational operation. These are the operations. So by combining several operations, like the select, the pi, and so on, this is called relational algebra expression. So relational algebra expression means it's a sentence, kind of sentence. Then it makes sense. Algebra operation itself, it's not very clear. It's too simple. But by combining several of them, it's very clear to understand what you want. Then database can access the data. That is called the relational algebra expression. So eventually, after we cover this operation, you should be able to write the sentence composition in relational algebra. So it's really similar as such a writing composition. So it's a relational algebra expression. This will be SQL language. Almost the same. So if you understand this first, the understanding SQL is really simple. Okay, so first we are going to study vocabulary, which is a relational algebra expression. Okay. Any questions so far? I spent a lot of time to explain the background, but that's very important to understand how this kind of algorithm has been improved and why we need such a thing. Okay. Oops. This is the old one, right? Let me erase this. So I expect. So let's consider one relation. So we have student employee relation. Employee table. So we have the SSN is the primary key and the ID and the name, address, and so on. We have data 111, the lead, and so on. So I'd like to access this employee table. How can you access the table? I need name is Lee. I need the department, DNO is 1, like that. Okay? So first approach to access the relation is you can access through the data. Data or the tuple. Also row. Okay? That's the one of that makes sense because when we define the relation, what is a relation? Group of data. Right? So we should be able to access the data by the data. We should be able to access the relation by data, by tuple, by relation. So first operation is it's called the sigma. It's a Greek letter. It's a sigma. Sigma actually access the data by the data. In other words, it's called the filtering. Filtering means we can give the relation name and condition like this. For example, I'd like to access the employee whose name is Lee, which means, for example, I'd like to access what? Employee, relation name. And the name is, condition is the subscript. It's Lee. Like this. This is the notation to use the sigma. So sigma actually is a filtering operation by data. Then there are a couple of important things. First, any operation, relational algebra operation, anything from now on, any operation input. Input is relation. It's a relation. Input is the always relation. Okay? And output of any operation, output is also relation. So, two things. Any relation, not only the sigma, but the from now any operation. Input is a relation, output is also relation. Okay? Input is a table, output is also table. So it would be better to make the name of this one after this. So for example, we are going to use the arrow. So actually this is the third one. Rename the relation. Rename relation is left arrow. So output of this is the result. Result is the relation name. So new relation name, new table name. Okay. So for example, in this case, the output is like the 1 Lee and CS like that. This is a what? Group of data. Okay? So it's a relation. Name is result. So let me change. I'd like to access the employee. I'd like to retrieve the employee. DNO is equal to 1. Like this. Then output of this operation is all employee. So 111, 112, 113, the 120, whose DNO is equal to 1. Okay? All employee whose DNO is 1 will be returned. So what is this? It's a result. You can name it the temporary, TMP, it doesn't matter, you can rename the operation, it's the left arrow. Then, think about the definition of a relation, group of data. It's a group of data, it's also relation table. Okay, so first operation is the sigma. Sigma is the select the data. Okay, it's called the selection operation. Selection operation with what? Condition. So condition can be subscript. Then, what kind of condition can we use? Equality. We can use name is equal to list. TNO is equal to 1 and so on. Equality. And also inequality. Salary is bigger than 30,000. Salary is less than 40,000, like that. Inequality. And what else? Not equal, yes, we can use that not equal. And also logical operation and or such a thing. Then eventually commutative rule is applied. For example, I like to access employee. So always it should have what? Input. Employee. So DNO is equal to 1 and salary is bigger than 10,000. It makes sense, right? So this is the condition used in the selection. One more thing, we can extend many ways. What about this one? So we can select the salary is bigger than 10,000 from employee. No problem. But this one is what? Output of this operation also relation, right? Is it possible to use the sigma again? Yes, it's possible. Why? This is what? Relation. Relation can be input. Input of another sigma operation. So for example, DNO is equal to 1. Then result 2. Result 1, result 2. Is it same or different? This one and this one.
Yes.
It's the same. So you can actually apply the one condition or separate. So this is the, what about this one? DNO is equal to 1 and salary is bigger than 10,000. Is it different or the same? It's the same also. So we can use any logical operation and commutative rule for the selection. So selection is the most powerful, the operation. Then at this time, we can already combine the two operations, two vocabulary into one sentence. So this is called what? Relational algebra expression. In your page 2 or 3, you need to create the relational algebra expression, which means you can convert English into the relational algebra expression based on your design. Okay? So this is the first operation. Second, when we access the employee table, I don't want all the output of a result. Result is all attribute, like the SSN, ID, name, DNO, and so on. All attribute will be returned. I want only specific attribute. That makes sense, right? So like, for example, I want to retrieve the first name and last name of employee. Not social security number, not ID. I need only first name and last name. Okay? So at that time, we can use the second operation it's called the pi. In Greek letter, it's a capital Greek letter pi. And input is what? Relation. Output is also relation. At this time, though, we can list attribute. List of attribute. that you want to retrieve. So this is the pi, and this is called projection. Projection allow for the user allow specific attribute. So for example, let me erase this. I want to retrieve first name and last name of employee. So what will be the input? Relation. What? Employee. And which operation? Pi. Then last name, comma, first name, F name. This is the projection operation. Then output will be like this. All employee, but first last name and first name. So then this is what? Group of attribute, group of data. It's also relation. So we can do the same thing, result. The result is like this. So this is the projection operation. So we have two operations. One is by data, another one is by the attribute. So we can actually do the several things. What about this? Pi L name employed, pi the F name. Are they same one? No, this one is not the same. Once you got the two, the one, you do not have the first name here. So we cannot commutative like the selection. Okay. However, sometimes I want to rename. So L name is too long. I'd like to use L N, F N instead of this name. At this time, we have another rename operation, rename column. This is a row operation. In Greek letter, it's called a row, R-H-O, row operation. Row operation use, for example, row, rename, same order, FN. So output of this one will be LN and FN. Okay, you can rename. There are two rename. One is rename of relation, rename of table. Another one is rename of column. Okay, that is called the row operation. Then we can combine. Is it possible to combine selection and projection? For example, I'd like to retrieve the first name and last name of department number 1. Department number 1 is selection. First name and last name is projection. How? So, first you need to decide which relation you are going to access. Which one? Employee. Employee. Then, department number 1. ENO is equal to 1. Output of this one is all employee whose department is 1 will be returned. All attribute. We don't want all attribute. What? This is the relation. So it's the input of projection. Last name and first name. And result. So final result relation is this way. So this is called relational algebra expression to retrieve the data for specific attribute. Anyone who ever used the SQL before? It's very similar as the SQL, right? Yes. So almost the same. So later, when you study SQL, if you understand the relational algebra, it's just the kind of the programming language part, just to convert. So that's the reason understanding relational algebra is it can be used for many other languages also. But let's keep doing. So this is the input is a relation, and we can combine two operations to create the relational algebra expression. Also, what if I want to change the column name like the L and F and result? Even you can combine three relational algebra expression. Relational operation for one relational algebra expression. So one relational algebra expression is like a sentence consisting of three vocabulary, three operations. Okay. You can do whatever you want. For example, I'd like to access the social security number whose salary is bigger than 10,000. How can we do that? The first employee whose salary is bigger than what? The 10,000. And I don't need all attribute, only social security number. Then final result. Then output is like this. SSM 111, 112, 120. Whose salary is bigger than? Okay. So this is the relational algebra expression. One more thing. This is the one relational algebra expression. What about this way? First, DNO is equal to 1 employee. Then TEMP 1. So we create the temporary relation 1 for selection operation. The temporary one is like the all employee whose DNO is 11111, like that. Then last name, first name of temporary one. Does it make sense or not? It's okay because relation. This one is a relation, so can be input. So temporary 2. So temporary 2 is delete everything, and this one is last name and first name. Then final result is the row LN, FN, the TEMP 2. Is it okay? Yes. It's okay to use the three relational algebra expression. Final output is L and F. So this one relational algebra expression, the one, and this is the combining three of the algebra operation. They are identical. So either way is fine. So you can use one relational algebra expression. You can create this, or you can step by step, operation by operation by operation. Either way is fine. So sometimes this one looks better, but sometimes at one shot it's easy to understand, depending on the problem. But mostly, if you create the one sequence later, this one is better. But sometimes you cannot solve the problem at once. At the time you can separate. Either way is fine. So for example, in your the project and homework exam, so you can use either of them as long as your output is correct. Okay. So let's use the example in here. Any question? It's very simple to understand. It's not complicated. More important thing is practice writing. So you can learn the new foreign language from textbook. It doesn't help. More important thing is practice. You need to talk in Spanish. You need to talk in the other language, the English. I never use the English until the college. I never meet anyone who speak the English. So I study English only grammar and for exam. So terrible. So that's not a good way to learn to study the new language practice. So in this example, the textbook use a lot of such exercise. Please do so. So we keep using the same company database. First one is the selection. As you can see, the selection is the kind of filtering. So you can see the input is the relation and the condition is a subscript. Like any condition can be used. Okay. So for example, this is our employee, the relation, like that. So we can use a commutative rule like the combine or separate and in order like that. So you can easily understand this. So for example, can you understand meaning of this? Translate in English. Looks like complicated, but if you understand the rule, it's simple. Employee.
In the department number 4 and your salary is greater than 25.
Or
Department number 5 is
5. In case of 5, it's higher than 30,000 employees. So this is the final output. Okay. So 5 is over 30,000. 4 is over 25,000. 5. So 3, the employee will be returned. So that's it. And the next one is a project. Project limit number of attribute. So we can list the number of attribute. So we can, it's not commutative, don't be confused, but we can list of the salary like this. Last name, first name, and salary. How many employees we have? 1, 2, 3, 4, 5, 6, 7, 8 employees. So when we list of the employee of the last name, first name, salary of the employee, it will be like this. It's also output is a relation. So we have how many? 1, 2, 3, 4, 5, 6, 7, 8. What about this one? We can select the sex and salary of employee. But problem is, check the how many tuple return. How many? 7. What about this one? 8. Why? We access the same employee, but this one is 7, this one is 8. Any idea? This is correct, but it has only 7.
2 rows are same.
So if you take a look at the salary and sex, male 25 and female 25. The Alice and the Joyce, they are the same sex and same salary. Why? The same data is removed. Why? What is this one? It's a relation. Do you remember? Relation must have unique primary key. Okay, that's the relation. So any duplicate data will be removed in relational algebra expression. That is one thing different from SQL. SQL will return as it is. That do not remove. But however, according to the relational algebra, the expression, it removes the duplicate data. So because of the definition of the relation. So finally, we can create a relational algebra expression. We can create the one bit or separate. Either way is fine. Then we have the rename operation when you rename the column like that. So the 3 operations are basic operation, can do most of the query later. Okay. So please be familiar with to use that. So for example, this one, if you can understand first the meaning of the expression is the position, then you should be able to create. So for example, this one, employee, I want to access the last name, first name, and salary of department number 5 employee. Okay, then it will be like this. But same approach, if you separate employee first, department number 5, so it's the same result. Okay. The next class, we will continue the relational algebra expression. So idea is, where does the relational model come from? It's a set theory. Can we use the set operation? Yes, because it's a set. So we can use union, we can use intersection, a minus, and the intersection, so on, difference. So next class we will continue the set operation. Eventually, have you ever heard about the join operation? Sequel is one of the kind of signature operation, important operation in SQL is a join operation. Yeah, we can collect any data from the different source. So we will talk about the join operation next class. Okay, we do not have exercise lab today. The next week, after we little bit cover the SQL, we will start. The Thursday, we will start the exercise. Until that time, you should be able to access your MySQL database. Free to delete and create again. Okay? So most important thing is you should be familiar with the cloud environment. Okay? If you just delete and create again. Okay? Any questions? Okay, if you have any the due date on Canvas, please follow the due date. Okay. Also, one thing. So, for example, the page, the project page, asks the relational algebra. But if I do not complete the relational algebra, automatically it will be next step. Okay. So, if I do not cover any topic for project, it's not covered yet, it will be automatically next. It will not hurt the grading. Okay, thanks so much. We will see next week.